All right, so we were doing lines last time, and I ended class talking about parallel lines in the train, or no, I drew you a beautiful picture of a road. Remember that? All right, so I kind of got the feeling that y'all felt semi-comfortable with lines. Am I getting the wrong feel here? Anybody like really feel like lines are way out there? The reason I'm saying this is because I think I'm going to do like a big summary of all the ways that we can graph lines and all the different things, and then do examples. So just kind of like put a bunch of information about lines up here. Then after that, start working through problems. Okay, so let's begin with the summary of lines. So the lines that we deal with in this class, when I say lines, I think everybody thinks of a line on a flat sheet of paper, right? So we call those linear equations in two variables. And, in other classes, you can have lines in three-dimensional space, so they look a little different. So that's why we have to be specific about what we mean. So linear equations in two variables, the general forms that you'll see a line in. Okay, so the forms of equations that you will see. I started this last class, so I'll just kind of pick up. We have ax plus by equals c. That's one form. This is usually called the standard form. Next to this, I'm going to give you a specific example of what a line in that form would look like. Negative 5x plus 3y equals, let's say, 15. Okay, so this equation has two variables in it, and they're both raised to the first power. This is a linear equation in two variables, and if we graph it, we get a line. Okay, so that's one form. Another form, this is one that I think you're familiar with, y equals mx plus b, because we talked about that last class. This is actually called the slope-intercept form. This one was called the standard form. A specific example of this, y equals 4x minus 7. So if you could tell me in words like what the big difference between the standard form and slope-intercept form is, could you explain that to somebody, what the big difference is without making it too complicated? Or like, how would you convert from standard form to slope-intercept form? Move the x over. Right? So basically the difference between these two forms is that this one is solved for y. Right? Y is by itself, isolated. Here, y is not by itself. If I were to move this 5x to the other side and then divide by 3, I would have it then in slope-intercept form. So that's the main difference between the two forms. Solved for y, this one's not. And all the x and y's are on one side here, and all the numbers are on the other side, right? So that's the big difference between those two forms. And then, that's it. Those are the two forms that we have for equations of lines. Ow. Now, when we graph lines, when you graph a line on the xy plane, there's a couple of things that could happen. You could have a line that kind of tilts, I guess we could say that line kind of tilts up If you were reading this from left to right, or if you were like on a little roller coaster, you'd be going up here, wouldn't you? So you could have a line that tilts up a little bit. In this case, we say that the slope of the line is positive, greater than 0. And for the y-intercept, remember from last class that the m was the slope. The m is the slope. So this is really saying that the m has to be a positive number. So what's really cool about that is that if somebody gives you an equation of a line in slope-intercept form, you look at this number right in front of x. If it's a positive number, you know that that line goes up, like this. You're looking at it, right? The bigger the number, the steeper the slope. Now, you can also have lines that pitch downward, like this, from left to right. Here, your slope would be negative. Slope would be less than 0. What about a horizontal line, flat line? That's possible, right? We could have a flat horizontal line. We graphed those last class too. So what if we have a line that was like this, horizontal? What would the slope of this line be? 0. Okay, the slope is exactly 0. So positive slope, negative slope, 0 slope. And there's only one other type of line that we could possibly have, and that's what? Vertical. So what if you have a vertical line? I'll just throw it over here. What if you have a vertical line? What is the slope of a vertical line? Anybody know? It's undefined. M is undefined. And that just means that if you're looking at this equation right here, and you're trying to represent a vertical line, you can't use this equation. See, because m is undefined. Do y'all remember from last class what the equation of a vertical line has to look like? What is it?
Y in a number? No. Yeah.
This has to be x is equal to some constant. X is a constant. That's the equation of a vertical line. And notice that x equals, like for example, x equals -3, right? Just means move 1, 2, 3 to the left and then draw a vertical line. Notice that this equation does not look anything like this equation, right? It doesn't look like this. This has x's and y's. This equation does not. And so the slope is undefined because it kind of tells you, look, you can't use this equation. All right, so those, I just want to make sure we understand positive slope, negative slope, 0 slope, undefined slope. Let me draw you another picture. And again, I'm just summarizing all the different things about lines. That way we can do some problems. If you have a line, draw a line here. There are two important points on a line. This one is called the X-Intercept. I'm going to put X-Int for X-Intercept. And this one right here is going to be the Y-Intercept. Do all lines have to have an X and a Y-intercept? No. Look at this one right here. Does that have an X-intercept?
Yes.
Yes, but not a Y-intercept. This one has a Y-intercept but not an X-intercept. So there are two special cases where you would not have both, but otherwise you should have an X and a Y-intercept. If there's any tilt at all to the line, then you should have an X and a Y-intercept, right? Now remember how we find those last class? How do you find the X-intercept? Set y to 0. Solve for x. How do you find the y-intercept? The opposite, right? Set x to 0, solve for y. So this is actually a method that we use for graphing. If we want to graph a line, all you have to have are 2 points. So we just find the x and y-intercept. Once we have them, we draw a straight line through them. Now the other thing we did last class was that we graphed lines using the other form. That was the slope-intercept form. So if you have y equals mx plus b, then we can graph the line by first doing what? What do we do to start? You graph b. B is the y-intercept, always. So let's say b was here. You would put a dot here, wouldn't you? And then what do you do from there?
You graph m using right.
You use the m, which is the slope, which is equal to your rise over run. And that will tell you from this point, you know, how far to go up and over, and then draw another dot and draw your line. So your rise and then your run. You know, your rise is up and down, your run is left and right. Is this kind of a summary? Does this all make sense? Okay. We got 2 more little things to do, and then we'll start doing some examples. Just make sure we're clear again on parallel and perpendicular lines. All right? So given 2 lines, I'll call them L1 and L2. I'm just using that notation, just, you know, we have a line 1 and we have line 2, right? Then they are parallel if what? If they have the same slope, right? If they have same slope, they are perpendicular. I'm just going to put perp. Is that all right? They are perpendicular if slopes are what? Opposite reciprocals. So they have to be reciprocals of one another and opposite in sign. So we said opposite reciprocals. Okay. All right, so everything we've had up, everything I've put up here is stuff we've talked about, right? In some sense, we've done something with this like last class. Okay, the next thing I'm going to put up here, we have not discussed. It doesn't mean you don't know it, but we have not discussed this, so this is kind of new, I guess you could say. So all of the information I've put up here is basically like, hey, if I give you the equation of a line, if I give you the equation, can you graph it, right? Or if I give you the equation, can you tell me if it's parallel or 2 lines, are they parallel or perpendicular? That's me supplying you with the equation and then asking you to do something, right? But there are other things we need to be able to do where I don't give you the equation. Instead, I give you some information about the line and ask you for the equation, all right? So to do that, we do something else. So we start out with this idea. All right, given 2 points, bless you, on a line, we can always find the equation of the line. somebody gives me 2 points on a line, I can always find the equation of that line. And here's how we do it. So I'll do it with a little picture. Let's say that somebody gives us the point x1, y1. That means this is the x-coordinate of the first point, y-coordinate of the first point. Then they give me a separate point over here. Let's call it x2, y2. There is only one line that goes through those 2 points. So how do we find the equation? Does anybody know how we find it? Okay, so what formula? We're going to use a couple of them, actually.
Don't you do like x1 minus
Yeah, like you're going to subtract 1 and yes.
Minus x1
divided?
And then divided by something. Okay, yes, that's the right formula. What we're actually doing first in that calculation is we're actually going to find the slope of this line. Okay, so the first step, if somebody gives you 2 points to find the equation of the line, step number 1 is to find m, which is the slope, right? We find the slope of the line. And to do that, we calculate it as follows. y2 minus y1 over x2 minus x1. You cannot get those flipped. You cannot do the x's on tops and the y's on the bottom. It must be the y's on the top and the x's on the bottom. Why? Why do you have to do it that way? It's rise over run, right? Rise is up and down, right? Aren't our y values the up and down? Run is the x. X is left and right, isn't it? So rise over run. This is what this is giving us. Right, so we find m first. Now, m by itself is not the equation of the line, right? The equation of the line is either going to look like standard form or slope-intercept form, right? Those two forms. So to find the equation, step 2, I actually need another formula. And this formula I have not given you. This is kind of a new formula. So for step 2, we are going to use what's called the point slope formula for a line. And here's the point slope formula. Does that look familiar? So somebody gives us 2 points. First thing we do is we calculate the slope of the line by using this. Once we have the slope, we use this formula that will automatically generate the equation of the line. So all I have to do in this formula, the only things that have to be replaced, I need to replace that, and replace that. I leave the y and the x completely alone. So I will actually do an example of this in a minute, all right? So you can see this all happening, but that's going to be our procedure. I need to mute my phone, I apologize. My 8-year-old daughter, yesterday, I had to run a quick errand. Just in the neighborhood, I had to go run up to the mailbox. And I didn't want to leave her alone in the house, but we just upgraded our alarm system. So I said, I'm going to set the alarm, and I'll be back in 5-10 minutes. You're going to be good. Oh, I'm good. So it's a new alarm, and I accidentally set it for away, which means that the motion sensors were active. So like, I gave her the phone to call me. I gave her our house phone, and so like 2 minutes later, she's calling me. She's like, alarms going off in the background. I traumatized her. So I'm getting a text right now, but from her sister, but I think they're okay. Yeah, they're good. They're all traumatized. All right, so someone gives you 2 points. You can get the equation of the line. And I think that's it. I think we'll be good to go from that. So let's start working some examples. How about the review? Do y'all want to look at just work some problems on the review? Or do you want me to start with the ones on the sheets first? Let's try and do both. Okay, I'll do the ones off the sheet first. Simultaneously. All right. So I'm just going to put these problems up. I want us to sketch this line. And do this one. 2y plus 1/4 x equals -2. Yeah. All right. When it comes to sketching lines, if there's anything you're going to take away from today, when it comes to sketching lines, you have options. You have basically two options. You can either find the X and Y-intercepts and draw a line through them, or you can put it in slope-intercept form first, and then go to B, and then do your rise over run to get to another point. Your choice. Do you understand the difference between those two methods? I think for this one, I'm going to do, because it's our first one, I'm going to do it both ways. And then on a test, I will never tell you which way to do it. I will let you choose how you want to do it, all right? I think in the homework, it does tell you, like, use the intercept method. That means find the intercepts, right? Even in your homework, I don't care how you do it. I just want you to be able to do it one of the two ways, all right? So let's try the first way. Let's do the intercept method first. All right, so for the intercept method, what I'm going to do is find the X and Y-intercepts. So let's find the X-intercept. To do that, I look at the equation and I replace what with what? Y with 0. So if I put a 0 here, the 2's gone, right? Yes? Yes. And all I'm left with is 1/4 x equals -2. Any questions with that? And I'm solving for x, right? So if I solve for x, I need to get rid of a 1/4 in front. So how can I get rid of a 1/4 in front? Multiply both sides by 4, right? And what would you get? X is -8. Now remember, this x equals -8 is really a point on my graph, isn't it? And if you want to look at it like an ordered pair, like an x and a y, the x is -8, but what's the y? Well, what did we replace y with to get this going? 0, right? So this is the point -8, 0. So on my graph, if I wanted to start graphing this right now, I would move to left 1, 2, 3, 4, 5, 6, 7, 8. There's -8. I put a dot there, and that would be one of my points. That's my x-intercept. We clear? Yes? Okay, I only need one more point, right? Just one more point and I'm in business. So find the y-intercept. And to do that, I set x equal to 0. So if I replace this x with 0, it's going to kill this term off. I'm just going to have 2y equals -2. And then divide both sides by 2, you get y is -1. So again, written as a point, what would the coordinates of this be? 0, -1. Why is it 0? Because x was 0. That's how we got to this, right? We said x has to be 0, and then y has to be -1. So that means I go down 1 on the y-axis, and I draw a point, draw a dot. And then using something that's relatively straight, I draw a line. And you miss the point, just like that. Just make the point bigger. There we go. Okay, there's your line. Is the slope of this line positive or negative? Negative. Do you know what the slope is? Not really, right? Could you calculate the slope? Yes, you could calculate the slope. How could you calculate the slope if you needed to? Rise over run. You could call this point x1, y1, call this one x2, y2, and then use the formula, right? So I guess what I'm trying to get at is this. With this equation, the intercept method produced our line pretty quickly, right? We got to it pretty fast. The thing we didn't get with it is it didn't produce our slope for us, right? We didn't see the slope. We'd have to do further calculations to get the slope. Yes? Okay. But we still have a picture. So we're done, right? That's what we were asked to do, sketch. Now let's do the other method, which is to put it into slope-intercept form first. So the slope-intercept method that method right there, again, if I was just walking down the street talking to somebody about the slope-intercept method, which happens a lot, you know, then I would really be just telling them, hey, you're just solving for y, right? You're just going to take the equation and solve for y. That's really what this means. So I take my equation, and I try and isolate. I'm going to try and isolate this y term right here. So I would want to move the x term over first, right? Get that thing out of here, move it to the right. It would become negative on the right-hand side. Now I'm not showing that work. I'm trusting you're all comfortable with moving terms to the other side. And what would be the next step? Divide by 2, right? So let's be real careful here. What happens when you divide 2 by 2, it goes away. You just have the y here. So I've got the y by itself, but I need to figure out what happens when I divide these by 2. So how about this one divided by 2? Just get minus 1 over there? Okay, but what's this divided by 2? So you have negative 1/4, right? And you're dividing this by 2. That's what you're doing, right? Which is really the same as, and this goes back to something I showed you a while back. This is really doing this. So you have a fraction over a fraction. And so I told you I'm going to flip this fraction up. And when I flip this fraction up, it's going to come up here, multiplication as 1/2. Does this look familiar? So what is that? When I take negative 1/4 x and I divide that by 2, what do I really get? Negative 1/8 x. Negative 1/8 x. Common mistake I see on that is, that people will do the division and they'll get negative 1/2 here. That's a very common mistake. Just make sure you're taking your time through this division, understanding what's happening. We good? Sure? Okay. Now, is this in slope-intercept form? Does this look like y equals mx plus b? Yes. This does look like y equals mx plus b. In that case, what is b? What is b for us here? Yep. What is it, though? Negative 1. And what is the slope of this line? Negative 1/8. Now, I have a question on that negative 1/8. Is it negative 1 over positive 8? Or is it 1 over negative 8? Which one of these is it? It doesn't matter, actually. It's one or the other. You get to choose, but you can't put the negative. You can't have the negative on both the top and the bottom. It's got to be on the top or the bottom, one or the other. Okay, so you can use either one, and you're going to get the same line. I'll show you that in a second. But let's go ahead and draw it now. You ready? So if I were drawing this from scratch, what I would do is start where? Negative 1 on the y-axis. There's negative 1. I would draw a dot right there. And then from that point, I'm going to move, and I'm going to use the rise over run. So you want to use this one? Okay, so this is telling me I've got to rise by negative 1, which really means down 1. And then the 8 on the bottom means to the right 8. So down 1, right 8. So down 1, right 8. 1, 2, 3, 4, 5, 6, 7, 8. And I draw a dot. Notice I'm moving from this point, right? I didn't start back here at the origin. Start here, down 1 over 8. And I draw my straight line. Yes? Now what if you'd used this one instead? You would have gone up 1, left 8. Up 1, left 8. Somewhere around there. And guess what? If you draw a straight line, It's the same, they're going to land on the same line. So it doesn't matter which one you use, you're in business. It doesn't look like it because I'm just sketching it up here, but if you took your time, it would be the same line. All right? Now, is it this one? Does it look like that is right? I think it is. It's the same line. So the advantage of this method is that now if I ask you what's the slope, right, you know it's negative 1/8. Where in the previous method you didn't know what the slope was, right? You would have to work for it. But the downside of this is there was a lot of room for error in here also, right? We could have made a mistake with that 1/4 being divided, right? So they have pros and cons. They both have pros and cons. Okay, let's try this one. Throw a little curveball at you here. Same instructions. Sketch this line, this example here. 5y equals negative 20. Sketch the line. So I've already given you a hint that I'm throwing you a curveball here. Is that in standard form, slope-intercept form? What's going on here? Or is there something else going on? Does anyone notice anything? There's no x, right? There's no x here. And if there's no x, that means you just have y is equal to something, right? If you divide both sides by 5 here, you get y is equal to negative 4. And what type of line is that? So how are you going to remember it? I mean, I remember it, but how are you going to remember it? Y being a constant. Just think about what that's saying. It's saying that your y value, which is up and down, is always the same. So if you look at a horizontal line, aren't all the y values always the same? The vertical line, are the y values always the same? No. Does that help a little bit? Okay. So here what we're going to do is we're going to draw y equals negative 4. We're going to draw a dot, and then every point that has that same y coordinate, and that's your line. See, you don't need to do the intercept method. You don't need to do the slope-intercept method. This one is just recognizing that it's a horizontal line. What would happen if I had changed this to 5x equals negative 20? Then it'd be x is negative 4, and then you'd have a vertical line, right? Okay, so just be careful with that if you ever see that. Okay, this one looks fun. Let me do one fun one, and then I'm going to ask you to do one on your own, so you can work together and talk to each other and help each other out, make a friend. All right, so this is straight out of the homework. 2/15 x minus 2/5 y equals 4. I think I'm going to change the problem a little bit just so you can practice. Well, no, I'll just do it. Who cares? Okay, there you go. Sketch it. So immediately you look at that and you get a little ill because you don't like fractions, right? So what would you rather do here? Would you rather replace x with 0 and figure out what y is, and then replace y with 0 and figure out what x is, or would you rather solve this for y? It's your choice. I don't care. Does anyone prefer replacing x with 0 and figuring out what y is over solving for y? Let's take a vote, since all of you are so vocal. How many of you want to do the intercept method? That means you're not going to solve for y. Intercept method? Okay. How many of you want to solve for y? Really? Okay. Interesting. Interesting. Okay, so I'll do what the majority of you want to do. And then I think I'll convince you after that that the other way would be much cleaner. All right, help me solve for y. What would you like me to do? If you want me to solve for y, we're trying to get it to look like this. Right? If you want me to solve for y, then what would you like? You want to move the x thing to the other side? Let's move this to the other thing. Okay, hold on. I can only do one thing at a time. Let me move this over, minus. It becomes negative on this side. And we still had the 4/5 there, so it's plus. Okay, so that, I'm sorry, now what?
Did you find the least common denominator and with the fractions?
Oh, you clear the fractions, like, to begin with, just to get rid of them? Yes, absolutely, you could do that. That's probably what I would have done to start. Because fractions suck and people make mistakes, so you can get rid of the fractions right away by multiplying both sides of the equation by 15. But that wasn't suggested first, so I'm not going to do that. All right? I'm going to continue with this. We can still clear fractions now, but would you have done that? Would you have? How many of you would have cleared fractions at this point? Okay. So if you would have cleared fractions, I think that's good. If not, you're going to have to struggle with some computations here. Because how do you get y by itself at this point? You divide through by this, right? So you would actually have to divide this by negative 2/5, this by negative 2/5, and this by negative 2/5. And then you'd be doing a lot of flipping and multiplying, right? Fraction over fraction. That could get a little messy, couldn't it? But I think I'll do it, right? I mean, I don't like fractions, but I'm not afraid of them, right? Okay, so tell me about this fraction right here. Negative over negative. My answer should be positive, shouldn't it? Okay, so let me just do that on the side real quick. 2 over 15 is really going to become times 5 over 2, isn't it? Because I'm flipping that. I'm ignoring the negative because I know negative over negative is positive. The 2's cancel. 5 goes in there once, goes in there 3 times. So what am I left with there? 1/3 x. Okay? And then plus, no, it's not going to be plus. It's going to be minus because now I have a positive over a negative. So when I do that, 4/5 times 5/2. So I took this fraction, flipped it up. I'm ignoring the sign because I already know positive and negative is negative. And then I do some simplification here, and I believe this comes out to be 2. So that's it. Oh, that's not so bad as long as you're comfortable with working with fractions. It's not so bad. And let's go ahead and graph that. Y-intercept starts it, right? So you go negative 2. Bam. And then from there, what? Rise by how much? 1, so up 1. And then what? Right 3. There we go. Draw a straight line. We're done. Okay, just to show it, if I would have cleared fractions from the very beginning, I would have multiplied this by 15 and this by 15. Let's just see what would have happened. When we multiply the 15 here through, the 15's cancel, we would have got 2x. And then 15 here, we would work that out, and you get minus 6y. And then equals, on this side, 15 over 5 is 3, so you should get 12 over here. It's just a little easier to work with if you look at it that way. And then you'd still do the same thing. You'd move the 2x over, then divide by negative 6, and you would come up at the very end with these same fractions right here. I'm not going to work it, but you see what I'm doing there? Okay. Now, I said I would have done the intercept method, right? That's what I said I would have done. So if I were doing this problem, I would have just said, okay, let me find the X-intercept. So I would have set y to 0, and that would have given me 2/15 x equals 4/5, right? It would have killed off that whole y piece and just left me with that. And then I would have divided both sides by 2/15. And this would have just become x. And then this one, when I flip it, I think I did that over here, didn't I? No, I didn't. So this would become 4/5 times 15 over 4. We get 3 there. So x is 3. Is that right? Hold on. No. What did I do? 2 over, yeah, this is a 2. I apologize. That's 2. So this reduces and becomes a 2. So this should be 6. I know I'm working that fast. I'm only doing it just to show you like what would have happened, all right? And then if I found the y-intercept, would have set x to 0, I would have had negative 2/5 y equals 4/5. And when I solved that, I would have got negative 2. I'm not going to show it, but I would have done the same thing. Divided through, and I would have got negative 2. And so my x-intercept would have been 6, which would have been out here. And my y-intercept would have been negative 2, which would have been here, and I would have had the same line. So you pick your poison there, whichever method you like, go with it. All right, you ready to work one on your own? Okay. I'm going to actually give you 2 to work. Does anybody have that review with them by chance? How many problems on there ask you to graph a line on the review? Let me see.
Oh, yeah, right here.
Let's
There's
see.
2.
Oh yeah, graph,
3.
graph. Okay, so there's a couple of graph problems on there. I make sure you know how to do this. And I think most of you have done this at some point in your life, so this should not feel like completely foreign territory to you. All right, 1/4 x plus 1/2 y equals negative 2/3. I'd like for you to sketch that however you wish to. And then the next one, these are not necessarily that one of them's harder than the other or anything like that. 1/3 x minus 2y equals 2/3. You're free to talk to one another at any point in time.